Refactoring is a crucial technique in software development that focuses on enhancing the internal structure of existing code without altering its external behavior. This process involves making systematic changes to improve code readability, reduce complexity, and enhance maintainability. By refactoring, developers can clean up technical debt, which in turn helps to prevent future issues and improve overall software performance. It's not about adding new features but refining the design of the code after it has been written to make it more efficient and understandable. Refactoring ensures that the codebase remains adaptable and easier to manage, allowing it to evolve more efficiently as new requirements arise or the existing systems expand. A proactive approach to coding is essential for maintaining high-quality software that is easier to debug, test, and extend. To take a simple example, consider the problem of naming. Imagine changing a method name from calc to calculate total with tax. The intent behind the method becomes much clearer and the code is self-documenting. Another common situation is where you have a block of code that does a specific task and which you can extract into a separate method. In the example, the process order method is shorter and clearer when it is broken down into its two main steps. Sometimes methods are so tiny they're used only once. In such cases, it makes sense to inline them, right where they're needed, simplifying the flow of your code. Here the getTotal method is redundant and can be replaced by a simple assignment. Another opportunity to clarify the intent of your code is to replace magic numbers with named variables or constants. The example illustrates this by replacing the hard-coded value 0.05 with a variable called discount rate. And for those complex expressions that make you pause, introduce a variable to explain what's happening, making your code immediately more understandable. When a class becomes too large and takes on too many responsibilities, it violates the single responsibility principle. The solution is to split it into smaller components. Here, the customer's address has been moved to a separate class to add clarity and make it easier to reuse. If a method in one class uses data from another class more than its own, it may be better suited in the other class. This promotes cohesion by ensuring related functionality stays together. This refactor illustrates an application of the law of Demeter. The discount logic is more naturally tied to the customer class, as it depends on customer properties. Moving this method ensures that classes deal primarily with their own data, improving cohesion and making the code easier to understand and maintain. During development, complex conditional statements can sometimes develop as new cases emerge. By applying polymorphism, we can clean up the code significantly, letting each subclass handle its specifics. Refactoring should be a routine practice, integrated at multiple stages of your workflow to maintain and enhance the integrity and efficiency of your code. Code review is a prime opportunity to tackle refactoring. This is when you can catch and deal with code smells or complexity issues before they merge into your main codebase, ensuring only clean, maintainable code progresses. After your first draft of code, take a moment to step back. Initially, you might focus on functionality, but revisiting the code to improve clarity and structure can make a huge difference. This refinement makes your code simpler and more modular, setting a solid foundation for future additions. Before adding new features or addressing performance concerns, assess and refactor your existing code. This approach not only prepares your code for new functionalities but also optimizes performance without altering external behaviors. Regularly integrating refactoring into your development process, especially when dealing with legacy code or preparing for new team members, ensures your codebase remains robust, understandable, and adaptable. Continuous attention prevents the buildup of technical debt and maintains code quality, easing the onboarding of new developers and revitalizing outdated systems. In summary, refactoring is essential for enhancing code quality, readability, and maintainability. Refactoring techniques align with core software engineering principles like single responsibility and encapsulation. Aim to integrate refactoring into your daily development practices to help ensure the codebase remains adaptable, reducing technical debt and preparing it for future growth.